Application problem, finding the length of a ski lift. To find the length of the span of a proposed ski lift from point P to Q, a surveyor measures angle. So this symbol, this symbol you see right here, this is called angle DPQ. Angle DPQ to be 25 degrees, so this is 25 degree DPQ. And then walks back a distance of 1,000 feet to point R, measures angle PRQ to be 15 degrees. So I have that on my picture. What is the distance from P to Q? So this is the distance that they are looking for. I'm going to let X be the distance from point P to point Q. All right, so first thing is look at DPR. So DPR. What is the degree of DPR? So DPR is a straight line, so we call that a straight angle. What is the degree measurement of a straight angle from this point to this point? The answer is 180 degrees. So this is 180 degrees. We have a straight line, and then we cut 25 degrees right here. What about the other side? This is 180 minus 25 equals to 155 degrees. So at this point, we can say two things. Number one, angle QPR is equals to 180 minus 25 equals to 155 degrees. So this will be 155 degrees. So what else do we have? So do you see that there is a 10 over there? So the 10, I put it there already. So how do I get the 10? The 10 is angle PQR. That is equals to the sum of three interior angles, 180 minus 155 minus 15 equals to 10. So 10 degrees. So the angle Q is 10 degrees. All right. And then what are they looking for? They are looking for X, right? So they are looking for X. So now we got all three interior angles. And then we have the 1,000, and then 1,000 is facing the 10 degree. So using the law of sine, I have sine of 10 degree divided by the side that the angle is facing, which is 1,000, equals to X is facing the 15 degree. So I have to use sine of 15 degree divided by X, and then you cross multiply. So X times sine of 10 equals to 1,000 times sine of 15 degree. So X is equals to 1,000 divided by sine of 15 degree times sine of 15 degree divided by sine of 10 degree. So we have 1,000 times sine of 15 degree. Again, this must be in degree mode. Divided by, remember to close the parenthesis before you divide, divided by sine of 10 degree. So that is equals to around 1490.48 feet. So that is the height from point P to point Q. Speaking of the degree mode, so on your calculator, you press the mode key and then make sure, so in my calculator, that is line 3. Make sure that is in degree. You don't want to use radian. All right. So to quick, you can press second and mode. So in mine, I'm going to press the X. All right. So that is the first problem. So moving on to the next one, when you do application problem, math is not the hardest. The hardest part is you have to sketch the graph. So in the next problem, this problem has a graph, but in the next one, there is no graph. So this one is finding the height of an airplane. An aircraft is spotted by two observers who are 1,000 feet apart. As the plane passes over the line joining them, each observer takes a signing of the angle of elevation of the plane. So what is elevation? Elevation is you start at a horizontal line. So let's say elevation 40 degrees. So that means you draw a line. So this is a straight line, right? Do you see the line moving up and down? So starting at 0 degree, and then you move up 40 degree. So that is elevation 40 degree. So back to this picture, we have a 40 degree, and then we have a 35 degree. They are asking for how high is the airplane. So that means they are asking for this H. And again, the airplane is not in the middle between those two observers. So let's take a look. So first, I have one oblique triangle. And then I have two angles. So why don't we find the third one? So the angle PRQ, RQ, that is equals to 180 minus 40 minus 35, right? Subtract the other two interior angles, that equals to 105. So this is 105 degree. All right, so 105 is facing the 1000. I can use the law of sine. So this is sine of 105 facing the 1000. And then we have, what are we looking for? How high is the airplane? I cannot find h right now. So how about this? Let's find one of the sides. Let's find this size, x. And then I will cut it into a smaller triangle and then use the SOHCAHTOA to find the height. All right, x is facing 40 degree. So this is sine of 40 degree divided by length x. And then you solve for x. So cross multiply, you have x times 105. I mean sine of 105 equals to 1000 times sine of 40 degree. And then x is equals to 1000 times sine of 40 degree divided by sine of 105. Okay, we have 1000 times sine of 40 degree, close parenthesis first, divided by sine of 105, close parenthesis, and then you press enter. So x is approximately equal to 665.46. The unit measurement is in feet. So I just got my x, but that is not what I am looking for. I am looking for the height of the triangle, the height of the aircraft. So this one, let's call that R, PQR, right? I don't have point R. Okay, now let's cut this into two triangles. I'm going to draw a triangle right here. This is a right triangle, and then this is my height, and then this is a right angle. This is 35 degree. This is a 665.46. I don't know the base. Again, you cannot assume that the aircraft is right between those two people. They didn't say it. You cannot assume that it's true. Okay, so this one I will be using the right triangle trigonometry, SOHCAHTOA. So I will be using sine. So I have sine of 35 degree. O opposite. Opposite we don't know, that is h divided by hypotenuse, 665.46. So h is equals to sine of 35 degree, whatever that equals to, times 665.46. So let's see what the height equals to. 665.46 times sine of 35 degree, and then you have 381.69 feet. That is the height of the aircraft. All right, so that will be all in this part. In the next part, I will do two more examples.